Last year, NESL started a series of distinguished lectures with the purpose of bringing to NESL some eminent scientists and also leaders in science policy, communication, journalism, and other fields. The idea was to present some cutting-edge ideas and also to engage with scientists from the lab with the hope that we could form some lasting partnerships. So over the last couple of days, the first of these lectures for this year, we've been delighted to host Professor Dan Kahan, who's the Elizabeth K. Dollard Professor of Law and Professor of Psychology at the Yale Law School. Dan is an expert in the science of expert in science communication and risk perception. And I know many of you have had an opportunity to engage with Dan over the last couple of days with some pretty lively talks from what I've heard. Dan received his JD from Harvard Law School, after which he clerked for Judge Harry T. Edwards of the United States Court of Appeals and the D.C. Circuit, and also Justice Thurgood Marshall of the U.S. Supreme Court. After that, he worked for a while in private practice before joining the faculty of the University of Chicago Law School. After that, he joined the Yale Law School back in 1999. As is shown on here, Dan is well known for his work as a member of the Cultural Cognition Project. This is an interdisciplinary team of scholars who use empirical methods to examine the impact of group values on perceptions of risk and science communication. In this area, he's published widely on such topics as the public acceptance and denial of climate change, public reactions to emerging technologies, and also public understanding of the scientific consensus across disputed issues. So before we start with the lecture, and before I introduce Dan to ask him to come to the podium, just briefly, because I'd like to present you with this little award. And just as a memento of your visit here, and we're very pleased to
Well, yesterday you gave me that thing, and the thing popped out of it, and
know.
you were laughing and all.
This one, no tricks this time.
Okay.
This is no tricks this time. We're on camera.
Oh,
so
thank you.
This is just a little memento of your visit here, and hope you have had as interesting a time as we had. Following that, today's...
That's beautiful. Thank you so much. This is fantastic.
Put in your windowsill, reflects the light around. So today, without any further ado, today the title of the talk is Climate Science Communication, Who Needs to Know What and From Whom? Please join me in welcoming Professor Dan Kahan.
Thank you. Well, thank you so much, David, and that additional token of appreciation or reward it's really it's over the top, because just the opportunity to be here and to be able to share ideas and be able to contribute something to a project that you're engaged in, and that I have just tremendous admiration and excitement, and also gratitude for. And the idea that you think maybe I can help you with that in some way, it's tremendously satisfying to me, but also does furnish me with the opportunity to feel like I'm reciprocating in some small measure for the benefit that you create for me and for other people with the knowledge that you generate. And also just the really cool stuff. I mean, I've really had a great time here seeing what people do and talking to everybody. And you know, I'm conscious that, you know, if I talk that way, it's like, oh, we've all heard that. You know, since we've been in the public eye in this kind of like glamorous institution with the movie coming out and so forth, that features our work, everybody's like, wow, NCAR, UCAR, well, I'm so excited. But honestly, I really was interested in what you were doing even before Nate Silver wrote the book that featured your heroic exploits and stuff. And I was kind of confused, though, about why Brad Pitt was the person, you know, that was cast for Rich Loft, who was the main character in the book. You know, I didn't understand exactly. But then David said, well, no, that's because in that picture is not really representative, because he isn't wearing the hat that he typically wears all around the building. And so I do see the resemblance there. But I guess there's no more filming, so I couldn't be an extra or anything. But I've already, you know, I feel like I've talked too long without showing data, right? But here, this is a scatter plot of responses of a nationally representative sample from last summer to the question, an item, a survey item, how much risk do you believe global warming poses to human health and safety on a scale of 0 to 7? And I sort of color-coded the responses so that the extreme risk, hot red colors, down to the no risk at all, the bluish and the green. And on the y-axis, the people are arrayed according to their political outlooks, right? And you can see, it's a pretty striking pattern that from the liberal Democrats are up here with the red and the hot colors down here to the more conservative and the blue. And that's a pretty, I don't know, is that a big correlation? The correlation between people's responses to this item and this measure of their political orientations is as big as the correlation between the two items, out of which I constructed the political orientation measure, a 7-point measure of their identification with either the Republican or Democratic Party, and a 5-point measure of liberal and conservative ideologies. That's a kind of nice index of their views. And they're really strongly correlated, so it's a kind of a nice measure. But this correlates just as strongly with them. So I could add that to my scale and do an even better job in explaining variance on things like Obamacare and abortion, right? I mean, this is who they are politically. And another interesting, kind of useful thing, in case you're wondering, I hope you were, well, what about that measure? It's a really useful measure because the response people give on that measure, how serious you take the risk to be, will correlate about 0.8 with anything else you ask them that they can understand about climate change, including whether the Earth is heating up. Are humans causing it? Is it going to cause this or another bad consequence? Also, whether when the North Pole melts, how much will the sea level rise? I mean, they know kind of what the pro-climate change answer is, even if it's not. It's measuring just a kind of generic orientation towards climate change. But people are just as polarized, right, on the basic facts here as on anything else. And, maybe already this is, knew this. I don't know, do you know this? We also measured the science comprehension of the subjects in this study using a measure that combines some items from the National Science Foundation, science literacy, battery, substantive knowledge, but also various kinds of critical reasoning measures that assess whether you have the kinds of aptitudes and skills that are necessary to make sense of empirical evidence and to draw appropriate inferences from the kind of information you would get from science. So it's a science comprehension measure. And a population, there's no effect. It doesn't have any effect on, and necessarily too, on the variance and the questions about is the Earth heating up, are humans causing it? But that's really just very misleading because there's a huge effect. It's just that it interacts with people's political outlooks, right? So if you're just in the half of the sample that is to the left of the mean on the political orientation measure, yeah, the more your science comprehension you get, the more concerned you are about the risks, and the opposite for the people who are to the right. So in other words, the polarization is being magnified, not dissipated, by really the best measures we have of whether people are able to make sense of evidence. And this is an instance of what I call a science communication problem. Science communication problem, as I use it, just refers to the failure of valid, compelling, widely, aggressively disseminated scientific evidence to dispel very intense political conflict over risks or other kinds of policy-relevant facts to which that science speaks in a fairly clear way. Right? Climate change is the most conspicuous example of this, but it's not singular. In fact, historically, the kind of research that I do got started not by me, but by people like Paul Slovic and Daniel Kahneman, and Amos Tversky, Baruch Fischoff, because the puzzle was, why is the public confused about nuclear power when there's this much consensus in the National Academy of Sciences around pesticides and so forth? And we have the same kind of disputes about other issues, like today, like the HPV vaccine for schoolgirls, right? And if this doesn't puzzle you, right, I mean, it's kind of a sad admission of a deficit of curiosity, I think. I mean, this is weird. I mean, there's nothing weird about people who have different values disagreeing about what we should do about a big problem like climate change, right? Or people who have different values having different opinions about whether you should have the right to carry a gun or something. But people here aren't disagreeing about what to do. You know, they're disagreeing about what the facts are. There's no analytical relationship between whether you value liberty more than equality or vice versa, and whether the Earth's heating up, much less whether when you allow people to carry handguns, crimes go up or down. Yet these things are all interrelated, right? And you might say, well, there's no surprise, because these are complicated issues. Maybe some of them even the evidence isn't so clear. But if it was just that these things were complicated, we'd expect the kind of disagreement to be distributed in, I don't know, random patterns. It's certainly not to correlate with people's values, right? So what explains this puzzle? And the science of science communication is not just one thing, but one of the things that it is the use of empirical methods to try to understand the kinds of influences that would result in this kind of puzzling correlation between people's perceptions of risk and their values, and also to identify maybe ways in which you could try to dissipate that, because it really doesn't suit anybody's interests. They don't necessarily agree about what to do, even if they know what the facts are. But if they can't tell what the facts are, right? Because there's this kind of crazy correlation between their identities and the understandings of science, they won't know what policies even advance the distinct kinds of values that they have, right? So we want to make sense of this. Now, here's one explanation you can kind of see already doesn't seem to be doing so well, which is just that, gee, people are kind of stupid. They don't know much about science, right? Because in fact, the problem only seems to get worse, right? And that, to me, is the signature, really, of the science communication problem. Not only the polarization, but the magnification of it in association with the various kinds of measures we might have of how people are going to be able to reason with, recognize, right, deploy valid science, right? And do I have any time left? So what I'm going to do, I'll go through a few points here. I'll start with a claim, a cultural cognition thesis, a hypothesis really about what's going on, and then present some evidence. At that point, I'm going to kind of offer you a synthesis, really a kind of interpretation of the evidence. It's part descriptive, but in part, I guess, kind of evaluative or normative, and also a corresponding claim about how we should use the understanding we have and exploit this framework I'm suggesting, at least provisionally. If we use this, how far can we get to try to dispel some of the influences that generate this kind of science communication problem? Then, in the time remaining, I will talk about the communication of climate science. Well, you know, I would definitely want to get to this. So let's see. We'll start with the cultural cognition thesis. Right? No, really, this is just a claim. The hypothesis is that people will form perceptions of risk and related facts, at least on certain kinds of issues, in ways that are reflective of certain kinds of group affinities that they have, because those group affinities will actually be enmeshed in or interacting in some critical way with cognition, right? With the kinds of mental processes that they use to make sense of evidence. And stated that way, the cultural cognition thesis is just a particular instance or special case of a dynamic called motivated reasoning. And motivated reasoning refers to the tendency of people to process information, make sense of information, whether it's logical arguments, whether it's data, maybe even the brute sense impressions, in a manner that is responsive to some kind of interest or goal that they have that is independent of figuring out what the right answer is. Right? The classic study, maybe you know it, 1950s, the paper was called "They Saw a Game." Right? And the researchers using college students as subjects actually made sense there. They said, students from these two Ivy League schools, watch the tape of a football game because the referee made some controversial calls and we're just trying to sort this out. Right? And so the students, I don't know, from Penn said, "Yeah, what's going on? There's a Dartmouth alum here. He was really stacked against us." And the Dartmouth, "Oh, he must have been on the, being bought off by Penn or something like this." And this is motivated reasoning, that the stake that the student subjects had in a kind of solidarity with their group was actually influencing what they would see, right? Or at least that was the hypothesis, and it's been kind of shown that all kinds of phenomena that are like that. Lots of things can motivate people to assess information in some way consistent with a goal other than figuring out the truth, right? And so here the claim is, well, this is part of the science communication problem, right? People are assessing all manner of information about these kinds of risks and facts in a way that serves an interest or goal they have in connecting to a group. And that isn't always going to be convergent with the truth. And now the question is, like, what are the groups? And, I mean, here, this is consistent with that. You could say, oh, the groups are Democratic Party, Republican Party, or something. We use a different way to try to measure. Well, here's the way I think about it. I don't know. We know that this is the case, that people of different types seem to form these collections of these packages of views here. What is it? We can't see that thing in them. But, well, it's a kind of latent variable. We can measure it with different kinds of indicators, right, and try to test hypotheses. It's not anything. It's not politics. It's not culture. This is like the Bohr-Rutherford atom. Just come up with a scheme, a picture that makes it tractable. And if that helps, right, do something with it. And I think this is a better picture than right-left, and we can talk about it a little bit, but it doesn't really make a difference. You use one or the other, right-left, or this scheme, which is associated with the work of an anthropologist, Mary Douglas. You don't have a different theory, you just have a different measuring instrument, right? And we call it cultural cognition because Mary Douglas, she was an anthropologist, had the view that people's perceptions of risk would correspond to the kinds of associations that are characterized by holding groups, holding values about how society or other social organizations should be organized, that you could map out along these two orthogonal dimensions of how egalitarian or hierarchical are people, how individualistic, how collectivistic, right? And so the claim was that people who are more hierarchical and individualistic, they're going to be more risk skeptical. She has a story about this, they're going to perceive unconsciously that if the claims about environmental risk, usually mainly nuclear power, are credited, then that's going to create pressure to restrict those activities. And that would be disappointing to these people because commerce, industry, markets, these are important for them, not just materially, but even symbolically, because they're associated with human excellence. And the egalitarian, communitarian is already kind of suspicious of commerce and industry, markets. Those are the source of unjust social disparity. So, of course, they want to believe nuclear power and pesticides, everything else killing us. Kind of a controversial claim, and also just kind of a story. Look, we can find associations between people's perceptions of risk and their values measured with attitudinal scales that reflect these kinds of constructs, all kinds of interesting ones, right? And all of the kind of ones that we're familiar with as being the real hot button issues that divide people. And so you don't want to get into a conversation about that with somebody if you can avoid it, right? But we want to know it's cultural. That's our motivating disposition. Mary Douglas has this idea. But we want cognition. She has a story about this. I want to know, what are these discrete mental operations that would account for people who have these different kinds of associations converging on these understandings, right? And so, that's where the evidence comes in, right? So just a couple of I don't know what her view is. And in my view, it's exogenous. Like, I have a feeling it would just be the same kind of story you would get about how people form religious or political sensibilities and so forth. But, I'm not sure. But it also, for me, it's kind of, well, should I say this? It's morally exogenous too. Because if this is a problem, you see, there are two things we could do. We could either try to remove the conditions that make the values connect to the group associations, or we could try, if we know something about where these come from, to make sure we all have the same one, the smart one, right? And I want to say, well, no, you didn't have that in mind, you wouldn't, but some people would. And I think that that's really kind of, well, here, let me see some evidence. And I'll show you why that wouldn't be a good strategy, even if you thought you could do it. We did a study on perceptions of scientific consensus. Because, after all, the science communication problem, why isn't scientific consensus taking care of this? And we looked, we picked 3 issues on which we knew that people have, as they tend towards these kinds of outlooks, are going to be polarized. And we do an experiment. We say, well, take a look at this guy, he's a scientist, right? And he went to pretty good, well, one went to a great university, the other 2 kind of average. No, that's in my contract to say stupid things like that. Now, whenever it's Harvard up there. But, they're all members of the National Academy of Sciences. And the question is, does this look like somebody who you would give the time of day to? You or a friend trying to understand this complicated issue? If this person has done work here, do you think that this is somebody who you might want to consider in the views of and forming a judgment, right? And of course, it's an experiment, so we show half the subjects, the featured scientists, taking what we call the high-risk position. Climate change consensus is out there, it's real, the evidence is in, it's being caused by humans, all kinds of bad things going to happen. No, it's too early to say the computer models are unreliable. We need more evidence before we start doing all kinds of crazy things. Similarly, on the deep geologic isolation of nuclear waste, very, very dangerous. No, it's not at all. Right? Carrying the concealed weapons, maybe there'll be more violent confrontations, or the guns are lying around at home, more gun accidents, high risk. No, low risk, because, if people are carrying concealed weapons, we don't know who has it, everybody's on their best behavior. You don't want to piss anybody off. And so, now if you laugh at this point, I have an indicator, you see, of this latent variable of what your cultural outlook is. Now, what we find is that the perception of the subjects that the person in question, this scientist, he's an expert on this topic, is highly correlated with the fit between the position that scientist is depicted as taking and the one that predominates in the group defined by the values of the subject, right? So the people who are hierarchical individualists, much more likely, 54 percentage points more likely to say that's an expert when the expert is depicted as taking the low-risk position than the egalitarian communitarian would be, right? Similar effect sizes on all these issues. Now, you see, this is like they saw a game. These group affiliations are, in our study, what the college group affiliations were, and they saw a game. And they have positions on these things, and we're showing them evidence. Evidence, you might think, well, here's somebody who knows something, or evidence, too, of what scientists believe on this issue, and they're giving the effect to the evidence conditional on whether it is consistent with the position that dominates in their group, right? I mean, they're not updating their existing beliefs based on the strength of the new evidence. They're assessing the strength of new evidence, assigning it a likelihood ratio based on their existing beliefs, their priors, which are then the result of their cultural allegiances. And you see, I mean, this is just a model. If I say, hey, what do you think of James Henson or something like this? Oh, yes, he invented the Muppets. What a shame, he passed away. These people don't know climate scientists, you see, but they're going through the world being told things about what climate scientists say, right? And you ask them at the end, what do most scientists believe about this issue, that issue? And they go, every expert I can think of, every representation of what experts say that I can think of is on this side. Well, you've engaged in bias sampling, excluding as not evidence that has any weight, any contrary evidence. We would expect them to be divided then not just on these issues, but also on what scientific consensus is on them. And they are and have been for years, right? And here's another hypothesis you could reject, which is that one of these groups just hates science. You know, that would be, I mean, there are some people like that, I've heard. But these groups, they all believe scientific consensus is consistent with their view. They don't go around saying, you know, who cares about science? They say, you don't get it, right? And another hypothesis could have been, well, one of them is much better at figuring out what scientific consensus is than the other. Another reason we picked these three issues is that on each one of them, they're National Academy of Sciences expert consensus reports. Now, National Academy of Sciences isn't the Gallup, you know, polling operation of scientists, but it's still a kind of interesting benchmark, right? For you to see this kind of evidence on the division of these groups on what scientific consensus is, you could conclude that one of them is more in tune with what scientific consensus is, only if you believed it was more in tune than the National Academy of Sciences expert consensus reports. You want to know what the consensus is on that issue? Don't look at the National Academy of Science consensus reports. Ask an egalitarian communitarian. That's ridiculous. Neither of them is very good at it. They're both really good at selectively attending to the evidence in a way that predictably aligns them with their group. Right? Now, here's something, right, they agree on. What the weather has been like recently in their area is a good evidence of whether climate change is happening. Right? That's a robust finding. People get it all the time. But my co-author on the last paper, Hank Jenkins-Smith, said, okay, but what predicts their perceptions of what the local weather has been recently? It isn't the local weather. It's their cultural outlooks. If you're an egalitarian, you think that it's been very hot out recently. And if you're a hierarchical individualist, you think it's been very cold. They tend to live actually in the South, so if that was one of your explanations, that's not it, you know? Because, you know, much like, well, here, I've got some more data on this. Well, is it really funny? You know, sometimes it is, but it also gets kind of sad sometimes. If you look at, here, we're doing research in Florida now. And you know, we want to know, Florida, it's kind of like on the frontier of climate impact. You know, how do they feel about it? And this is the United States. Now I've just, you know, we use the cultural outlook measures. So I got these two. Well, really, what you can see is that, you know, it's kind of bimodal. They're polarized along that way of measuring the disposition as well. And you've got the polarization by science comprehension, which, by the way, is just a replication of research that we had done earlier. And now we want to know, well, how about Florida? You know, and it's the same thing, right? They're polarized too, and I don't know, you know, what you want to make of the difference. It's still very, you know, there's still magnification. Now, we also measured the kind of experience people were having with climate impacts. How many adverse events have you experienced? How many times have you flooded? How many times evacuated? How many times have you been without water, like for a week or more? You know, how many times has your property been damaged? Are your insurance rates, well, everybody's insurance rates, well, it doesn't help you. You kind of toss it out of the scale, right? But actually, you know, you got, I don't know if the mean is like 3, and some people it's 7, and some only 1. People have these adverse impacts from the climate. And we want to say, well, does that have any kind of relationship to their perceptions of climate change risk? I don't know. Do you think so? What do you think? What's the relationship going to, what do you think the relationship is going to be? You think I'm going to trick you? And yeah, see, like the professors always try to trick people. What is it? Come on, who wants to know the answer? What's the answer? What? It's flat, says somebody. I tricked you, you see. Because yes, it is flat if you do a population-wide measure, right? It looks like no matter how many times things have happened, it doesn't have any effect for the population. It's the lowest line. There's nothing funny happens with it. But actually, if you're egalitarian and communitarian, the more bad things happen to you, the more convinced you are that climate change is a serious risk. You're a hierarchical individualist, it doesn't really have much impact at all. You see? What happens? The hurricane comes in, it smashes down these 2 houses across the street from each other. And one guy comes running out, and he sees the other guy, and he goes, you bastard, I told you climate change was going to happen, and now we didn't do anything, the house is smashed down. He goes, what are you talking about, you bastard? I told you that if we had gay marriage, well, houses are going to get blown down, you see? And now, really, yeah, they both get low science comprehension scores. You can observe these things, but you can't observe what's causing that. You know, the significance you give to your observation depends on some theory you have about how the world works that isn't something you're in a position to figure out through personal experimentation or otherwise. Where do you get that? You get that from your cultural outlooks. And this, by the way, also helps us to deal with another very popular theory. This is the idea that the reason members of the public don't recognize the seriousness of climate change risks is that they don't think the way scientists do. It's not just they don't know very much, but you see they tend to assess risk in a kind of an intuitive, emotional, heuristic-pervaded way, very fast, unconscious, Kahneman says, not slow, analytically, deliberatively, you know. So they fixate on the risks that are really dramatic in emotional sense. You know, there's the airplane fuselage on fire, sticking out of the building, polar bear gets your attention for 5 seconds. You overestimate the risk of the more dramatic thing relative to potentially more consequential but kind of boring risk, because you don't use the kinds of methods and have the habits of mind that would allow you to recognize it. Now, the good news is that as soon as people start to have information that registers in the kind of currency of comprehension that is distinctive of their benighted system one slow thinking, when they start to feel it, then they'll notice it. No, because you don't believe it when you see it. You can only see it when you already believe it. And now, it was a hypothesis, but you do test these things. And when you do the test, you don't just keep recycling things. That was a plausible hypothesis. Here, another implication of this theory is that if the reason people are confused about climate change and aren't converging on scientific consensus is that they don't think the way that scientists do, then you would also predict that as they become more adept in the kinds of reasoning that are distinctive of science, the system two, slow, analytical, critical, they ought to converge, right? They ought to get the evidence. The people who don't know the evidence, they go with their gut. It's filled with crap, like what do people like me believe? But the people who are members of these groups who can think and understand it, they ought to converge. And I've already shown you, right, some evidence that doesn't seem to be happening, right? What's going on? This is consistent with the cultural cognition thesis. The idea would be, well, people aren't converging, they're going further apart. Because people are using, you see, their critical reasoning capacities to promote this other goal, stake they have in connecting to the group. Now, that's an inference you can draw. This is just observational or survey data. Let's do an experiment, right? So we do one. This is interesting. We say, hey, scientists have done an experiment. People love that, actually. That's why they watch Mythbusters. You think we're an anti-science society? Why do we have these two doofuses sitting on it? When the guy says, I have a question. What would happen if a penny fell through the Empire State Building? Would it go through somebody's skull? Oh, that's a good question. I don't know. Why don't we make like a model of it with shoot the penny into the water, the whole show? So people are tuning in. Two guys had a question. They were curious. And then they spent the whole time doing experiments. That's their idea of fun. That's the kind of society we live in. But they get into these kinds of issues. You tell them something about, well, here's some scientists. They want to know if a new skin cream was going to work. Sometimes it doesn't work. Sometimes the rash goes away by itself. Sometimes it makes it worse. So they did an experiment, of course. They treated some people with the skin cream, and they observed how many got better and how many got worse. They didn't give the skin cream to some people. How many got better? How many got worse? What's the result? And instantly, you know what the answer is. Right? That in fact, here, people are getting worse if they got the skin cream. Well, here's what people do. They say, oh, look, more people got better who used the skin cream than got worse. It works! Those are the ones who aren't very smart. Slightly smarter ones say, hey, look, not only that, but more of the ones who got the skin cream got better than the ones who didn't. It worked! Right? But you got to use all the information in the 2x2. That's why you draw it that way. It's a covariance detection. And so you got to look at the ratio. Right? You're 5 times likely to get better if you didn't use it. Right? 3 times likely to get better if you did, so you're more likely to get worse if you did use it, then if you didn't. And people make this mistake. And it's not because they don't know the math. And if you explain this to them, you say, this is, oh, you fooled me, I won't do that again. Yes, you will, because this is a critical reasoning task. Do you recognize the need to use this kind of understanding? You will, right? Here's what I'll tell you what we do. We have two versions of this. One in which the experiment is skin cream. The other is whether a gun control ban, is it making crime go up or crime go down? Use the same numbers, and of course we change the subject heading, so half the subjects see the experiment where the information properly interpreted suggests good results, skin cream, rash is going away, crime is going down, and half see a bad result, the crime's going up, and skin cream is making rash worse, and we want to see what happens. And you see, we anticipate that the people will get the right answer if they are high in a certain kind of disposition, numeracy, which isn't just math, but a capacity and a disposition, even a kind of intuition to recognize what you have to do to reason in a cogent sense with numbers and to draw valid inferences from numeric information. And this problem is known to be very hard. You have to be good at numeracy to get it. Well, both Democrats and Republicans are not too different in it. But you see, if the skin in the skin cream example, right, it doesn't make any difference whether you're a Republican or Democrat, but you're not likely to get it right until that's pretty close to like the 90th percentile on the scale, right? It's a really discriminating question for whether you have this capacity. Now, here you see, well, you're very likely to get the right answer if the evidence properly construed supports the position in your ideology, if you're high in numeracy. Otherwise, you can't even recognize what would be consistent with your group. But if the answer isn't consistent when properly construed, the evidence is properly construed with the position that's dominant in your group, you don't do any better as a high numeracy people than the low numeracy people, right? What's happening? The low numeracy people, you see, they're not able to recognize when the evidence, they're doing their best. No, nobody's being a hack here. They're trying to get the right answer. The low numeracy people would look like geniuses if they were just being hacks, as long as the evidence was consistent with what their ideological position was. They're trying, they can't even recognize it. You can if you have high numeracy. But when it's disappointing to your position, the way the referees call, might be, well, then the kind of seductive allure, of that heuristic signal. Oh, just look at this cell and that cell. You're being lured in, right? The seductive appeal of it, because it does gratify another stake or goal you have to be forming group convergent views. And you know something? If that's the way the world works, oh, I'll show you another thing. Look at this, I modeled it, and so forth and so on. This is like, if people just show this kind of crap, what are they trying to do? Intimidate people. You come up with we did a Monte Carlo simulation. Let's look and see, the partisans who are low in numeracy, how well, not very likely to get the right answer. They're very, very likely to get the right answer in the skin condition. And now there's polarization. But the interesting thing is that the degree of difference between the subjects who are low in numeracy, it's not as big as the ones who are high in numeracy for the reasons that I was telling you, right? They're the low numeracy people, they can't get the right answer. The high numeracy can if it's group value congruent, but not otherwise. So there's even more polarization among the high numeracy groups than among the low numeracy groups. That's why, you could do with culture too, by the way, you end up with this in the real world, because people are using their critical reasoning capacities in this kind of opportunistic way. That's not what the thinking fast, thinking slow account, which was perfectly plausible, you see. But more things are plausible than are true. That's why you collect evidence. And it's why you then update your view. If you're not just a storyteller writing for, you kind of grab in to decision sciences, heuristics and biases, plop them in, add water and stir, and you're David Brooks writing an article. If you really want to know the evidence, that's not it. It's the cultural cognition view. And, I want to interpret this. If you see this pattern, the polarization that is magnified condition on the critical reasoning capacities, the problem obviously is not too little rationality. The problem is too much. People are too good at extracting from the information the implication that will connect them with their group. Right? And why shouldn't they do that, you see? Because think about it. What you believe as an individual about the climate and climate science has no impact because you're not magical. You know, as a consumer, your behavior isn't consequential enough to make a difference. As a voter, as an advocate, any mistake you make in those capacities won't increase your risk or that of anybody else you care about. Right? Make a mistake, though, on the issue. Given what it signifies in our society about whose team you're on, you could be in big trouble. I go back to New Haven, march around with the sign, it's a hoax. I have tenure, but it's still going to suck, right? And how about Bob Inglis, right? World's most conservative congressman gets knocked out in the 4th District of South Carolina in the primary, right? Now, after Floyd the barber in the 4th District of South Carolina, guy comes in for the raise, the straight razor, hey, sign my polar bear petition. You'll be out of a job as quickly as Bob Inglis was. So you see, you don't even have to be that smart to figure that out. But if you are pretty darn smart, well, then you have a kind of resource that you can use to be even better. Not better at getting the evidence that's consistent with the best scientific understanding, but the one that is typical of your group. And you know, you do that because it's in your interest. It's rational even. Of course, it's a disaster. Because if everybody's doing it at once, you see, then in a diverse democratic society, people are less likely to converge or converge as quickly as they should on information that is actually relevant to the welfare of all of them. And guess what? That gives nobody any reason to change how they think, because that won't make any difference. And that's why it's a tragedy of the science communications commons. There's this misalignment between the collective interest in how people are using this information and the personal one. But it's not that they're stupid, you see. And I'll tell you another thing. You know, this is not normal. This is normal, right? This is normal. The number of issues where you see this pattern of the polarization that gets magnified conditional on the science comprehension is tiny in relation to the number of issues where there really isn't any kind of correlation, and the people who are the most science literate are tending to converge, right? You want to select on the dependent variable. Look at all the cases. Orders of magnitude more where this doesn't happen. And why then, you see? Not because people, in these cases, they understand. Oh, they get it about the X-rays, right? Or you see, the biologists are so much better at science communication than climate scientists. That's why everybody knows don't drink raw milk. Why don't you learn a lesson from them? They don't have any idea. They think that antibiotics, oh, that thing is working again. They think that antibiotics are as likely to kill the virus as bacteria. But guess what? It doesn't matter. See, they don't need to know that. They just have to know something else. Who the hell knows what science knows? The doctor. And you go to that person and you take the erythromycin. You don't have to learn all of that stuff. They're experts at knowing who knows what's known by science, you see, which is pretty amazing, actually, if you were to stop and think about it. But here's where they do it primarily. Here's where they're best at it. Because they hang out with these people, you know. They like them, so they don't get into fights if they're talking with them. They can read them better. They know who's got the right answer and who's bullshitting, right? And so they tend to use their rational faculty for figuring out who knows what's what within these kinds of groups. But, you know, that's not a problem because, you see, science comprehension is a culturally random variable. If you don't believe that, then that's probably a result of motivated reasoning, too. I've done a study on it. All these groups are amply stocked with people who understand how to understand science. Right? And they all have intact mechanisms for transmitting what's known to their members. Because if there was a group out there consistently misleading its members on what's known, and that's important for their lives, you see, they'd be dead. And even the people who say they don't believe in evolution, they actually are just as likely to understand natural selection and get that point. Right? And so it's not a problem that it's kind of insular like this. You know, they all end up in the same place. So this is normal. It's not normally distributed. They're all bunching up close to the right answer, and these guys are giving them, well, you know, that's normal. See what's happening, you think about it, Republicans and Democrats, even the ones who are low in numeracy, they don't have bad acne. Well, what's going on? You know, the high numeracy guys are telling them not to use this or that skin cream, right? That's normal. This is pathological, both in the sense of being bad, as I described, but also being unusual. What's happening here is that positions on matters of fact are becoming entangled with these kinds of significations and meanings that transform them into badges of membership in these groups, at which point the stake people have in protecting their status within these really important groups will dominate the one that they have in forming truth-convergent understandings. Those meanings that glom on to these issues, they're a kind of pollution in the science communication environment. Right? The science communication environment, the sum total of processes and cues that enable people amazingly to, with very good reliability and accuracy, figure out what's known to science, much more than they could possibly comprehend or verify on their own. The things that interfere with that in the unpolluted science communication environment. And so what do? You want to protect it, you know? Protect the science communication environment. You want to remove the pollution. You want to disentangle the positions from the identities. And you want to use, you see, the same methods of science that you could use to try to figure out what's going on, to figure out what kinds of things we could do. First of all, to prevent it from happening. Because none of these issues are born with these meanings. You know? They acquire them. And not just because of mendacity and strategic behavior. They could be done that easily. There'd be a lot more we disagree about than we do. But oftentimes by accident and misadventure. And then, you know, if we're not trying to acquire the information on how this works and connect it with the production of the knowledge we have, we're idiots. Right? I could show you an example of how something like that. But I don't know, we're running out of time, right? You want me to tell you something about how to communicate climate science? I'll skip through this. Does that make sense? Or unless you want to stay later. And so I'd stay here forever. I don't know. And it's not just because like New Haven sucks. But I'll skip ahead. If you want, I'll come back to it. But here's what I'm going to do. Skip ahead to, I was going to show you, you know, a model of how you might do that. And that's what it is. And then the question is, well, how do you make in the world a result that reflects what you just did in the model happen? And you know what you have to do? You have to do some more experiments, because more plausible conjectures about that, too, than are true, right? So you have to do field experiments, as we're doing in Florida. But here, communicating climate science in a polluted science communication environment, right? And I'm going to say, like, really, the most, you got to start with this. Who needs to know what from whom? The biggest mistake, the biggest fallacy that you use the science of science communication to overcome, the truth is manifest. You know, res ipsa loquitur, it speaks for itself. You don't have to, ridiculous. You know, how do people know these things? And there's a process, and if you just ignore it, things will get screwed up. The second biggest fallacy, you know, one size fits all. What's the Latin for that? Well, we don't have time for that. But, you know, something like that. You know, one toga size fits all. That's Rome or something. But, you see, it's not the case that the same kinds of processes that are being used to help a decision maker understand a model, a dynamic model. That's exactly the same kind of techniques you would use to help a person who's trying to make a decision about whether to have an elective surgery that has risks on both sides. And of course, exactly the same thing that you would use as a science journalist to help somebody understand the latest discovery about the Higgs boson. And then, of course, the same thing we would do to help ordinary citizens converge on. No, these are different kinds of things. And so you have to ask, you know, who needs to know what from whom? I want to say there are two kinds of audiences here to think about. First are ordinary decision makers. They need to know normal climate science. And they need to know it from you, right? Because if you don't ignore the denominator, in all of these cases where we are making decisions and we have policies informed by the best evidence, we listen to the scientists, and only an idiot wouldn't. And there are ways in which you can improve the comprehension and tractability of the information that you generate. But decision makers who genuinely want to use it, they want to hear from you, right? And I think you're doing a good job at that. That's not what the problem was, you see. Here, with ordinary citizens, they need to know the normality of climate science. And they need to know it from themselves. Right? We do this work in Florida, advising 4 counties that are trying to promote local policy making informed by the best climate science. And they say to me, oh, you're going to help me with science communication? Tell me what should be on my slides. And how about my tie, red or blue? And I said, well, maybe a time will come. That's the important issue. But the first thing is, what do people in the community think about what you're doing? Because if you get a polluted science communication environment, you're screwed. Even Bob Inglis won't be able to do what you want to do. Right? And I tell them 90% of the people, they don't know who the Southeast Compact is after 4 years. The other 10%, half of them think it's a basketball league. They're never going to see your slides. They're never going to hear from you. But they're going to find out from other people at some point who will tell them what's up, you see. So what do you want to communicate? Not this. Not to them. This isn't the problem. Oh, if you just had a better, some confidence interval. You don't need to tell them this. They live in it, and half of them think it's because of gay men. That's not what you tell them. And certainly don't communicate this because you see you're trying to tell them 97% of scientists, you moron. That's exactly the information that is telling them that this is an issue on which their side believes this and that one believes that. You're only actually making it worse. What do you want to do? And it's really... I say, you want to communicate normality. You see, that's normal. And this is how it happened. People, see how good a science communicator I am? I'm telling them, what do you mean? What the hell is that? This is what it should look like. And it happens. People, this is what you should do. They can't, the information they're missing is that it's normal for people like them to understand that this is valid science. It's getting blocked out by this. So show them this. It's you, the commissioners, your ordinary people. 3 of you are Republicans, and 1 is a Democrat, and you're saying we got to do this. Show them. Now, most of them aren't going to these meetings. That's okay. They want to know what their neighbors who care about these things do. Hey, your neighbor is going to the meeting to talk about this issue. And by the way, so is your employer. And if you don't listen to Al Gore, but FedEx must know what it's doing, and it's saying that to do this. And, people who are your coworkers and so forth, the same people who taught you that you should go to the doctor when you're sick and take it. It's normal. It's even banal. They won't be that interested in it. They'll turn the channel. But at that point, they'll recognize what the answer is. They'll be oriented in the way that they normally are. Fill in their inventory, right, of images of what it means with people like them who are showing we recognize the validity of this and we use it. Right? We use what NCAR is giving us. Show them that. Now, I want to say, I could have just stopped there. Maybe I should. I would have. So if I'm going over, it's your fault because I kind of was going to stop here. But I realized in talking with people here in the last couple of days, there's actually one more audience, curious people. You should think about it. They want to know the wonder. You got to communicate the wonder of climate science to them. They got to hear this from storytellers. This is a story. It's really great. Every chapter is a really compelling story about dynamic modeling. Here's how it worked in baseball, and we outsmarted the old guys, and so forth. Here are earthquakes. Well, it doesn't really work there, but here's the cool things you can learn from it. And, we can predict terrorist events, at least, what the frequency and magnitude. And economists, they're idiots. And you hear all these stories, and the next one's about climate science. And wow, I want to hear that story. You might be a guy who wants to hear it because you love nanotechnology. I was going to show you a study. If you tell people about nanotechnology, a lot of climate skeptics, they love gadgets. They want to believe in climate change. Who wouldn't? There's going to be nanotechnology, flying saucers, levitating up there, and there being a thermostat system. And maybe we'll even have synthetically bioengineered E. coli pilots. Think how cool that would be. I'd love to see. They're curious about this. And that's a storyteller. Yeah, Nate Silver's a storyteller, but if that's a storyteller too, that's what we got in the book. You're wondering, he's a good storyteller. He made it really exciting and interesting to curious people. There's another storyteller, right? And there's some curious people out there trying to figure out the answer, to did climate cause this or that? And he's saying, well, it's like baseball, it increases the likelihood. He's not trying to gimmick, he's trying to make it understandable to the person who's curious, you see. If you're a scientist and you're also a storyteller, then do that. You see, you won't necessarily do this. You've done it. You're a citizen scientist. Doing this, it's not going to fix the polluted science communication environment because sadly most people aren't curious, and that's not what the problem is. But you see, who cares? This is intrinsically valuable, right? And you want to do it. That's virtuous. You want to do it because it's right, because how the hell did you get a job like this? I haven't worked since June 30th, 1993. I just get to think about things that I'm interested in. What kind of person would I be if I wasn't reciprocating by helping curious people to know these things, right? So you do that too. It probably helps somehow with climate. But even if it doesn't, that doesn't matter, right? And you can improve on your methods of doing that actually too through the use of empirical methods. Because another thing you can do as scientists, in addition to just doing really great science and communicating it in a competent way to decision makers, and if you want to, tell stories, is support, the remedy for the deficit that got us into this problem in the first place, that we haven't made an investment in understanding how people know and how to connect it to the production of what we know that is commensurate with the value of the tremendous knowledge that science gives us. And this is a problem in our culture. Our science culture in the National Academy of Sciences is saying, do something. What should you do? It's not clear. There are lots of things you can do, but do something, contribute your part, model it, and tell us what you're doing. You're doing it. And I talk to people here. We're trying to figure out how we can be sure that the great stuff that we produce makes its way without misadventure to the people who can use it. And we're trying to study that because we ought to think about that too, right? And so you are contributing in that way as well. And maybe it'll help with climate change. But, if we haven't learned from climate change how to overcome the science communication problem, we're missing a huge opportunity at a minimum, right? I'm out of time. Otherwise, I would tell you about this really cool experiment. But, so... Web page? What are you talking about? All right. Okay. Did I go too long here? Do we have time for questions? I'm not in a hurry. Like I said, maybe I'll miss my plane.